Yeet. Alright, you don't get the full transition this time. Anyways, welcome back to the nightmare. We got probably the worst calculus chapter we have so far, which is approximate integration. But first we got a big news, which is that Microsoft Whiteboard got an update. Hang on. I think the side is a bit wrong. Let me fix it real quick. And make this a bit smaller. And this is fine. Now, yoink. There we go. First, I noticed that the whiteboard now starts in full screen and all my shortcut keys are broken, which is not a good sign. But it looks like it's got a pretty clean interface. There's even these things. I got nodes, shapes. Oh, I can draw shapes. Might help with graphs. Images, there was always images. Reaction. Ooh, sticky notes. And of course, text. I still don't know what this does. I click it, it seems to not do anything. This button here toggles pin selection. I put all my old pins back, the white, gray, and blue. And of course the background is still here. Oh, also, one of the better changes, one of the changes that I really liked is, let's say I draw something. Now if I use the eraser and touch it, the entire thing disappears. That's probably my favorite change so far. And it says rulers coming soon. I don't know what the ruler was used for. Never actually used it. But anyways, oh man, this is a chapter I absolutely did not want to do, because this is just a ton of algebra. Anyways, number 12 wants us to approximate the integral of e to the power 1 over x with an n of 8 using the trapezoidal, midpoint, and the Simpson's rule. So we got a 3-in-1 combo here. Why does my pen feel weird? Anyways, to make this easy on myself, I would want to probably draw a little chart. This is our x, and let's just say it's like this. And over here is f of x. If we want an n of 8, then we got every step would be 0.25. So we got 0, 0.25. Ooh, I think whiteboard automatically corrected my shape into an oval. That's cool. We got 0.5, 0.75, not 0 point anymore, 1, 1.25, 1.5, 1.75, 2. And that's only for trapezoidal and Simpsons. We didn't even consider midpoint rule yet. Anyways, ooh. Can't plug in 0. Plug in 0, you get a problem. So this is an improper integral. Oh man, right off the bat. I didn't write anything wrong, did I? Oh yeah, I did write something wrong. I wrote something very wrong. Namely, we're starting at 1. why does n have to be 8? Why can't it be like something smaller? This problem is made to cause me great suffering. Plugging 1 will get E. Plugging 2, oh my god. 5 over 4. E to the power 4 over 5. E to the power of 2 over 3. E to the power of 4 over 7. E to the power of 2. I think, am I doing this right? No. E to the power 1 over 2. Oh man, I should have used fractions instead of decimals. I thought decimals was going to be easier on my calculator. Now that is e to the power of 4 over 9, e to the power of 4 over 10, e to the power of 4 over 11, e to the power of 1 over 3. Right. Now, trapezoidal rule first. Trapezoidal rules wants delta x over 2, I believe, and then times f of x1 plus f of x2, no, 2 times f of x2 plus 2 times f of x3, and so on, all the way until f of xn. So we basically gotta sum all these together. And I am not doing this by hand. No way. This is going to take a very, very long time. Oh yeah, does lasso select still work? I haven't tried this out. Yeet. Yoink. And can I change color? Oh no. Cannot change color here. Oh no. Can't change the color anymore. But oh well, colors are already messed up, so we'll leave it be. Oh yeah. Delta x, that's a minus b. Delta x is equal to a minus b. No, b minus a, b minus a. B minus a over n. So that's 2 over 8, so that's 1 over 4. So we got 1 over 8. Let me actually switch my color. 1 over 8 times e plus 2 times e to the power 4 over 5 plus da 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 da. All the way up to e to the power 1/3. And let's try. Where's my e? You know what? It would probably be easier for me to write a program to do this. Anyways, don't mind me just typing in my calculator. Times e to the power of And that comes out to approximately equal to 3.534934. And that is by the trapezoidal rule. Ooh, look! This is beautiful. Microsoft Whiteboard put it into a box for me. I like this one. I like this. I just hope they fix the shortcut keys. Or maybe it's a driver problem and the manufacturer of the driver needs to fix it. But my god, was that tedious. You know what? I seem to have a slightly better idea what to do. I got a slightly better idea. Now let's move over here for a second. Wait for it. This will be a little surprise. Now, where is it? This is it. Hell yes. But actually, where did it go? Refresh. There it is. Okay. Oh my god. Update Java version. Oh god, I just gave a spoiler, didn't I? Now then, I just have to add something. Window capture. And idea. Damn, I'm gonna have to accept the fact that the window size is gonna be weird. Yoink. Alright. So quite a while ago, I was too lazy to do homework, so I wrote something to do it for me. If I remember right, this was for binomial expansion, so like x plus 1 to the power of 100. Eh, it actually worked. How do I run this? Is my run thing still here? Yeah, run mass tester. I wanted to make a GUI for it, but in the end I got too lazy because I finished my homework and I didn't need this anymore. So I don't think I was... Oh, I did start it. I did try to start a little GUI, but command line is more than enough for now. But anyways, this thing can expand pretty large binomials. Except we don't actually need binomial expansion. So what I'm gonna try to see is there anything I can salvage from this? Anything that could help me? And what did I even do? Oh my god, I look back at my code and I'm like, what the hell did I do 2 years ago? Oh well, this is only for binomials anyways. Oh yeah, if you put in y, it works too. There are some problems, like here, where it's x to the power 7 times x to the power of -16. I didn't really take in consideration having 2 of the same characters. But it still works fine. It worked for the homework. What can I do here? I don't think there is anything that we can really scrap from here. And I don't think I'm going to be writing another one of these programs. Ooh, I don't need feed calculator. Well, yeah, there was a spring roll thing, which was a recursion problem. I did it to show someone else before. And let's move IntelliJ to our side here. And ooh, how's that? Uh-oh, that doesn't look good. That does not look nice. What's going on? IntelliJ, get over here. Alright, that's a little better. Let's write our own calculator. I'm not even gonna bother to write classes. I'm just gonna type new lines here. Let's still have int x. Or rather, let's put double x. That's our variable x, double n. How do I want to do this? Oh, low battery. Let's ignore that. We don't need the project view. Public void question 12. Int x, int n. Let's go 12b. Or rather, this would be reusable, so we don't even need to do this. No, we need a and B. Let's do it all here. A is 1, B is 3, N is 8, and X. Or rather, we should say for double X equals A. X is less than or equal to B. x plus n equals to our interval, which is b minus a over 8. Alright, this should be over n. B minus a over n. Now B wants midpoint, so let's actually do this. Double trapezoid, double midpoint, double Simpson. Let's call this approximate. And A and B. Nah, too lazy. Public void Q12B, and we want to take a double X, and instead of void we return a double. We return, what is it? Mass dot E. Mass dot pal of E to the power of 1 over X. Let's see. Trapezoid. These should all default to 0. Trapezoid is plus and equals 2 to 12 of which shall be X, right? Initialize order of values, initialize variables. There goes all my typos. Midpoint is equal to, bingo. How would this go? I feel like we should be doing this a different way. Yes. Place that somewhere. Let's do I. That's a lot easier to understand. So this will iterate 9 times given that n is 8. If I is equal to 0 or I is equal to n, too many pipes, then and else. So if I 0 or I equals to n, we could x will be equal to a plus b minus a over n times I. Sounds about right. Trapezoid would be Q12x. Or let's call this f. Oh, that looks so clean. Our function f. And if we are doing Simpson is going to be the same f of x. Otherwise, trapezoid is going to be equals to 2 times f of x. And Simpson is going to be equal to... we will need another else here. We need another if statement. I just realized something. We could get a delta x is equal to b minus a over n. And here we can just do delta x times I. Okay, midpoint is a harder one because we need to do midpoint plus and equals f of x plus delta x divided by 2. That would give us a midpoint, and that is only if I is not equal to n. But down here it would be a bit more straightforward. If I is 0, it takes that. If I is not 0, it comes down here. There's probably a smarter way to write that. If, let's see, so we want index like 1, 2, 3, 4, 4 times 4, or no, 1, 3, 5, 2, 4. Okay. If I is even, trapezoid, not trapezoid, Simpsons plus n equals to 2 times f of x. Else, Simpsons is going to be 4 times f of x. And let's write some prints. Trapezoid sum. Alright, so let's do this. Trapezoid equals times and equals delta x divided by 2, right? Delta x divided by 2. Midpoint times and equals delta x. Simpson times and equals delta x divided by 3, if I remember correctly. Trapezoid approximation. Let's just call it trapezoid. This was gonna be midpoint. This was gonna be Simpson. Midpoint, Simpson. Approximate. Oh, fine. We can be static. We can be static. Let's bring our function up here because I think our approximate method is complete. And let's actually give it int double A, double B, int n. N has to be an integer. We're gonna approximate from 1 to 3 with interval of 8. Run. Perfection. Now I don't have to do math anymore. Anyways, what was I doing? Oh, I got distracted again. So this is trapezoid. I should probably change my color. Let's make it a little thicker. I like the thicker pin. Now midpoint. No, don't correct that, Microsoft Whiteboard. Midpoint. That is going to be delta x times f midpoint 1 plus da 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 da, so on. And that is going to be equal to, we should probably write a little of this out. So that's 1/4 times e to the power of, oh, what's the midpoint? 1.12, no, 1.125, yes. Plus e to the power of 1.375 plus da 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 da, so on. Oh no, I can't change color again. No, it has to be perfect. Color needs to match. That's a rule. 1/4 times e plus e to the power 1.125 plus e to the power of 1.375 plus da da da, so on. And we get that it's approximately 3.51528. And that's by the midpoint rule. Box at Microsoft Whiteboard. Yes! That is so satisfying, having a perfect rectangle. Now then, let us move on to our final part, which is Simpson's rule. Simpson's rule says it's gonna be delta x (1/3) times f of x1 plus 4 times f of x2 plus 2 times f of x3 plus 4 times f of x4, so on until we get to f of xn. Out of space. Let's make this a little smaller. We can zoom out a little and it'll still be able to write. And that's gonna give us 1/12 times e plus e to the power, no, plus 4 times e to the power of 4/5 plus 2 times e to the power of 2/3. And so on, keeps going until we get to e to the power 1/3. And that is going to give us approximately 3.522375. Simpsons. The whiteboard is correcting every single one of my O's. And another perfect rectangle. Fantastic. Now I want to check the actual answer. Is there a calculator online that I can type it into? Let's see. Ooh. Sundal Lab coming up with a Simpsons rule calculator. This is probably much better than mine. Let's see. Integral from 1 to 3, but e to the power of 1 over e. No, 1 over x. And go. What is this? I just wanted Simpson. That's not Simpson's rule. Oh, it's calculating the margin of error. No, I don't want the margin of error. I just want the estimate. Come on. There's a Desmos graphing calculator that's doing Simpson's rule. Really? That's cool. Hey God, that is really cool. Okay, finally found one. This is e to the power of 1 over x. Lower limits 1, upper limit 3, subintervals 8. Calc. .522, 3746. Perfect. How about midpoint rule calculator? I'm just gonna verify that everything I did is working. Yeah. E to the power of 1 over x. Lower limits 1, upper limits 3, number of rectangles 8. Oh, typo. Go. 3.515244748. All right, fantastic. But now I got another problem. Can I write some set that interprets a function from a string? There's probably a library out there for it, but I don't wonder if I can try to write one on my own. How would I be able to do that though? Let's try it. With a healthy dose of recursion, we might be able to just write a single method for it. But now that I think about it, I can write one that interprets a really simple function. But let's say here's the thing, if I have parentheses, I can use that, but with 2 parentheses, that's a little harder. especially with my parentheses like this. Because how would I get from this parenthesis to this parenthesis? I can write one that interprets a really simple function with just one or two parentheses. This might take a bit of time. Let's say start with the simplest thing. Let's start by assuming that we have very simple calculations like x plus 1 or x minus 1 or x to the power of 2. But oh my god, this will be so annoying to deal with. If function the index of rather contains parentheses else. Imagine I have no parentheses. Oh my god. But then I would need to get all the plus, minus, multiplication, division. Unless I require you separate everything with space bars. It's a lot easier to just do it this way. Or I should probably be using a scanner. I don't know if I even remember how to use a scanner though. Oh, new scanner. Scanner dot, what can I do here? Let's use the limiter. Let's say we force you to use spacebar to make things easier for myself. Oh, but it already uses spacebar by default, doesn't it? delimiter is already spaced by default. Well, we'll leave it in there. It looks nice. String, or rather while scanner.has next. We don't need that. If scanner.has next double, let's use double. How do I get the first one though? Let's see, has next. Where to check that? If it's a double, let's do the string next concurrent equals scanner dot next. If current dot equals x or ooh, how would I get a number? Double dot parse double. Would need a try catch for that. Oh yeah. Try double dot parse double current catch. It should be number format exception. And we're just gonna ignore it. Yeah, ignored. This looks nice, doesn't do anything. Parse double. Boolean is num. Is false. Is num is true. Oh man. Something I do want to know is scanner.delimiter. What is pattern? Pattern string rejects. Can I make it have multiple delimiters? Hmm. You know, I think I have a little better, slightly better way of doing this. Hmm. How would I go around this? Let's still have the very simple function of 1 plus x times 2. We will first try to solve the multiplication. Yeah, no, this is something I'll figure out on my own time. I still have work to get done today. Anyways, we were done with... Can't believe I tried to write this program to make my work faster, but ended up getting sidetracked. And next up we got 19. 19 wants to know the integral from 0 to 1 of cosine of x squared dx using trapezoid and midpoint. Wait, no, trapezoid was interval 8 and to the midpoint was interval of 8. And that's A. B wants to estimate the error in the approximation, and then C has something else. So A, let's use our program. From 0 to 1, interval of 8, our function is going to be mass dot cosine of x times x. See how simple that is, but how would I go about converting a string to a function? I need to know. XP4J. Ooh. What's that? Is that included? We have a couple expressions. Java bean, sun tool. Oh my god. X4J, how do I use this? The G-strut shunting yard algorithm. Okay. This looks amazing. All right. Before we do this problem, we're gonna have some more fun. First off, where's need to add some kind of framework support. Okay, it's not here. We will once again need our. Where's my project view? There you go. We're gonna first let me fix my Java version really quick. Tamarin. And we're going to where is add framework support? Maven. Okay. All right. Anyways, ignore all that. No. Do we need a repository? Let's see. What's this? Why is this red? Hang on a second. Let me see. Oh, I remember now. Dependencies. This goes in here. Same for repositories. Goes in there. Now let me copy paste the Maven Central. Here's for Maven Central. Hopefully it's in Maven Central. Validate. Let's download sources and documentations. And click package because why not? Oh. Don't need that. That works. All right. Now, where is our function message? Here it is. expression. Ooh, here it is. Expression. Let me check the sample usage. Expression E is equal to new expression builder. Let's take a string function. The variables are going to be just x dot build dot set variable. Let's set x to x and return e.evaluate. There's probably a better way I can do this. How about we make approximate taking an expression. Set variables x to oh, just x. Set to x dot evaluate, and essentially the same things everywhere else. Fantastic. No. We can do expression E is equal to, so let's do this. Public static void approximate string double A double B int n. It's gonna read, that's gonna do expression E we no longer need F. Oh, let's call this function. And we're not going to say variable. Return approximate E A B N. Cannot resolve symbol in. Oh. Hang on. Oh, yes. Problem here. Wait. Can this handle cosine? Can this handle cosine? No. Gone. Comma. No need to return. Can this handle cosine? This is xv4j trig functions. Does have trig functions? Hmm. It looks like it does. Looks like it does have trig functions built in. Oh, yes, it does. Thank God. Thank God it has trig functions. Okay. Now let's put this as approximate integral. Everything here gets to go. And approximate that. Now, should I try to work on a GUI for this? Oh, this is using swing. I don't remember how to use swing. I've always been using the other thing. Right. Can I find some of my old projects to just snatch some code from? Learn repository. Hmm. Oh wait, hang on. Is XP4J capable of taking derivatives? Wait a second. Okay, no. Good, good. Commons Mass Library. Huh. Can I add that to my Maven? Yeah, no, you know what? We're getting way too sidetracked. I, I'm satisfied with this. This is okay. I'm satisfied with just this. Maven, don't need you, don't need you. Get Sin, we still want to keep you there. Alright, let's move you over. Now, we can finally continue doing order questions. Not gonna bother with the GUI. That's just the quality of life, and my life has no quality. Anyways, I'm gonna try to make this quick. A trapezoid of 8 is equal to 1 minus 0 divided by 8 times... Wait, no. Divided by 16. That's trapezoid times e to the power of... No, let me see. I think I'm okay. Not e to the power times cosine of, ooh, what over 8? No. Cosine of 0 squared plus cosine of 1 over 8 squared plus dot, which is approximately equal to 0.9023333. And that is T8 trapezoid rule. Now let's do B. M of 8. M of 8 is equal to 1 minus 0 over 8. Wait, that's 2. Trapezoid rule, everything starting from the second one is 2 plus dot so on. This one we just need to do regular. Cosine of 1 over 16 squared plus cosine of, what was I doing? 3 over 16 squared plus so on. And M of 8 is approximately 0.95, no, 0.905 620. Yeah, let me check my messages real quick. Anyways, so yeah, let me send someone a message. Anyways, there's an answer. Haha. Who's doing the math now? Anyways, let's keep the code here just in case anyone wants to read it. And B. Wait, no. This isn't B. B is the hard part. B is actually calculus. Estimates error. So E of T8 and error of midpoint 8. Okay, well, absolute value of E of T is gonna be less than or equal to M times B minus A cubed over n squared. Was that it? Oh no, my memory. Poor memory. Oh no, it's 12 n squared. Forgot something crucial. 12. And error of midpoint 8 is essentially the same, except now we have less than or equal to 24 n squared. Wait, was it squared? Was it squared? Yeah, it was squared. Good. Anyways, my favorite word now is anyways. Well, aside from yeet, yeet is still favorite word. My god. The biggest value is going to be 1 because cosine. Right? Because cosine can be at most 1. so, oh, that is so nice. Wait, no, no. I think I'm forgetting something very crucial here. What is M? I need to double check real quick. Yeah, of course. M. Let's get our gray. Annotation gray. M is equal to the maximum value of, hang on, of f prime of x? What? Give a second. Oh yeah. Maximum value of f prime of x, f double prime. So we gotta take derivative. If fx is equal to cosine of x squared, f prime of x is equal to 2x sine of x squared, or it should be negative. Negative 2x sine x squared. F double prime of x would be equal to negative 2x times 2x cosine x squared minus, no, plus negative 2 times sine of x squared. Is that right? Oh. Boring. So this is equal to negative 4x squared cosine of x squared minus 2 sine of x squared. Now, do I have to find the critical point? I will be able to guess this. I will be able to deduce it. Wait, the intervals from 0 to 1. So, oh god, do I have to take this integral again? I mean, do I have to differentiate this again? I don't want to. 4 times. Haha. Think about it. If I would guess it's x equals 0, which would be 0. Think about this logically. Yeah, no. F triple prime of x is equal to, oh my god, negative 4x squared times negative 2x sine x squared plus negative 8x cosine of x squared minus 4x cosine x squared. Did I mess up a positive negative sign or sine and cosine somewhere? Eight x cubed sine x squared minus 8x cosine x squared minus 4x cosine x squared. So this can just be minus 12. I'm falling asleep here, which I've never been able to do before. And this has got to be equal to 0. Oh my god. Might be just me, but I completely forgot how to do algebra. It can't even solve for x. I'm gonna see how this looks on decimals. Give me a slight idea. Cosine x squared that part makes sense. Negative 2x sine x squared still makes sense. How about 8x cubed sine of x squared minus 12x cosine of x squared. Looking a little messy. No. This is not it. Where did I start going wrong? Cosine x squared is right. And turns out, wait. No, that is Also correct. What about the next derivative? Wait a moment. That is correct? Really? Okay, so I did everything right. So no, no, I just realized how dumb I was. 0 f triple prime 0 is equals to 0. So if I have like a million in here, actually that would vary. At least now we know we got a critical point at 0. So maximum value, we're gonna plug in 0 to this function. So f double prime of 0 is equal to, we don't even know if this is a maximum or minimum, but we can I am just gonna assume, because I can only find this one critical point. Will it be 0 though? Now I'm paranoid. Cosine 0, sine of 0 is 0, cosine 0, we're gonna have -4. Wait, there's zeros here too. This doesn't make sense. This does not make sense at all. Ah, 1 second. Let's put in this in decimals. And where are my zeros? Wow, there is apparently another 0. But how would I have been able to solve that? How do I solve this? There's nothing I can factor out, no trig identities to use. Unless there is one that I'm not aware of. What have I done wrong? I need to check. Integral from 0 to 1 of cosine of x squared I have no idea what these word symbols are. Uh, yeah, I have no idea how to calculate its answer, but what if I do 4x times 2x sine x squared minus 3, this 2x squared cosine x squared. That doesn't really make it any more solvable. Two x squared sine x squared is equal to 3 cosine x squared. Well, aside from a calculator, who's gonna solve this? And the squared is not on the sine or cosine, otherwise it would have been easier. But the error cannot be 0, therefore m cannot be 0. Wait 1 second. Second equation, negative 4x squared cosine of x squared times negative 2 sine of x squared. It's going to be, looks weird, like every other function so far. It seems like I think I did something wrong, because this does not look like a derivative. There's 2 sine x squared minus 4 cosine x squared cosine 4x squared cosine x squared. Nothing seems wrong. Unless my calculator is lying to me. Did I mess up cosine and sine? No. What is wrong with this? Does a textbook have answers? To the back of the textbook. This is 7.7. 7.7, 19. My approximations are correct. But how does it get the error? Let's work backwards to solve for m. Apparently the right answer is 0.0078. So 0.0078 times 12 times 8 to the power of 2. Therefore, m is equal to 5.9904. Where does that number come from? Where does that come from? How long have I been stuck here? Did I get the error formula wrong? Let's check notes. Oh no, that's 7.8. That's the next one. 7.7. Margin error is... yeah. M is upper bound of f double prime of x. But if that's the case, This doesn't make sense. Fx x f prime of x but this does not look like f double prime of x. Yeah, no. Ooh. Double check question. Yeah, it's from 0 to 1. What does the actual question say? Estimate the errors. And C says, how large do we have to choose n so that the approximations Tn and Mn to the integral in part A are accurate within 0.0001? So we do need to solve for m. But m can't be 0. I believe it has to be something wrong with my second derivative. Although x sin x. Oh, I typed a plus. No, I typed a multiply instead of minus. Are you serious? That means we have another critical point at 0.994. Does that graph make sense now? But how do you solve this? I don't know if this is impossible by hand. Yeah, no. Well, I've been stuck here long enough. I'll do research on my own later. So negative 3.845. And f double prime of 1 is let's see. That's gonna be negative 3.844. Well, not a very accurate error. But I really don't know how else I could solve this aside from plugging into my calculator. But we're only allowed a scientific calculator, so how would I even do this? Let me actually put it in and see. So I'm curious. 8x. Ooh, where's x? So the power of 3 times sine x squared minus 12x cosine x squared equals, where's equals? So many buttons. Wait a second. Oh, there's an equation solver here. Now I have to enter everything again. 8x cubed sine x squared is equal to 12x cosine x squared. From 0 to 1. Uh, 2.5 to 1. How was that? Oh wait, I have to actually do solve. Yeah, no, not even the calculator is giving me an answer. No answer. But we'll have to go with this, I guess. We'll never know the truth. Anyways, absolute value of trapezoid rule. Wait, absolute value of a trapezoid rule. is less than or equal to negative 3.845 times 1 to the power 3 times 12 times n squared. And 3.845 divided by 12 divided by 8 divided by 8. So that's going to be E of t is less than or equal to 0.005007, but really we can't do that because significant figures. Now the right answer here is supposed to be 0.0078. So I have zero idea. Are we even doing the same problem? Unless we're supposed to actually try and integrate this. Hang on a second. Cosine of x squared from 0 to 1. Then just add in real quick compared to this we got. What is C? I've never seen that before. Oh, it's constant. But what? Fresnel integral. I have no idea what that is. Which means we don't actually get an answer. I'll leave it as this for now. I spent way too long on this, and E of midpoint would be half of that. Or was it the other way around? Is less than 0.0025. Wrong answer, but sure, I'll take it. Now C. C wants it so that E of, let me read the question. E of t is less than or equal to 0.0001. And it wants E of m is equal to or less than 0.0001. All right, so negative 3.845 over 12 times 8 squared is less than or equal to, wait, not 8, n, less than or equal to 0.0001. Next 3.845 over 24 times n squared. Not 25, 24 times n squared is less or equal to 0.0001. Calculated that and square root it. You get n is 57 at least. And for the other one, you get n is equal to 41 at least. Hey, at least I get a perfect rectangle this time. No, actual answer says 71 and 50, which are not our answers apparently. I have no idea what I did wrong here still. But alas, we've come to another question where our little calculator would come in handy for sure. Which is that? Question 20. Hang on. What question? $27. We need to redeem ourselves with this question. From 0 to 2 of x to the power 4 dx. This is a simple one. We can take the derivative of this real easily. And we want to find Tn, Mn, and Sn for n is equal to 6 and 12. We have our calculator. Then compute errors. So we do still need to find errors. Round to 6 decimal place. You may wish to use the sum command on the computer algebra system. I have my own computer algebra system right here. And I finally get to use it again. Let's move it down here a little. Okay. N. Let's do T6 is equal to can't wait to do this. Watch this. X to the power 4 from 0 to 2 with n of 6. And we're gonna copy that. And this time it's gonna be 12. Run! Oh, ha 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 ha! Oh, look at that. Beautiful. And T6 is... let's write estimate. Approximately, we approximate an approximation. 0.6, let me put this back down. 6.69547 T12, or actually let's do M 6 is approximately 6.252570. S6 is equal to approximately equal to 6.403292. T12 is approximately 6.4 no yeah 6.474023. Midpoint 12 is approximately 6.363008. Simpsons 12 is approximately 6.400206. Now compute the error. This one's easy. F of x is equals to x to the power 4. F prime of x is equal to 4x to the power 3. F double prime of x is equal to 12x to the power 2. F triple prime of x is equal to 24x, and f quad prime of x is equal to 24. Fantastic. Now then, error of t is, let's box this in first. This is part of our answer. Yeah, okay. Cuts out a little. The trapezoid is less than or equal to m. Let's actually find m. Maximum. This is how can I say this? Slope is always positive. Higher numbers maximum. For E, T, and error of midpoint trapezoid, m is equal to 2 times 2, that's 4 times 48. For error of Simpsons, m is going to be also 48. Wait, no, 24. So E of t is less than or equal to 48 times 2 squared over 12 times n to the power 2. No, that's cubed. Error of midpoint rule is about the same, except it's 24 now. And error of Simpsons rule is a bit more complicated. 24 times 2 to the power 5 over, what goes here again? 120 times n to the power 4. Is it 120? I need to check. Simpsons rule. Let's go check from notes. Well, why did I click that again? Oh yeah, Microsoft Whiteboard has a new loading screen now. I like how they're improving on the whiteboard. Although I don't know if it's improvement because all my hotkeys are broken. Now, 180. Good thing I checked because it's gonna be 180. Not 120, 180. So error of T6 is going to be less than or equal to, let's calculator time, 48 times 2 to the power of 3 divided by 12 divided by 6 squared. Hang on. So this is 0.88889. Error of t to the power of error of t with n of 12 would be less than or equal to 0.222222. Error of t, no longer t, m with interval of 6 is less than or equal to, oh, I just got to divide by 2, 0.444444. If m is with interval of 12 is less than or equal to 0.111111. Now error of Simpson's rule with interval of 6 is less than or equal to calc 24 times 2 to the power of 5. No. Divided by 180. Divided by 6 to the power of 4. Wait. Oh, I see the pattern now. I see the pattern. So this is going to be 4 times smaller. This is going to be 16 times smaller error if we double. If we double the interval, it's going to be 16 times less error. So 0.003292. Watch this. This is going to be 16 times less, I'm guessing. 0.0000. Bingo. No. 3 zeros. 206. Yeah. So is that 16 times less? Actually, I don't know. Let's see. Yeah, it is 16 times less. Hey, I'm right. When n doubles, error of t, and error of trapezoid, error of midpoint is, how do I say this, 4 times smaller. And error of Simpson's is 16 times less. Because this is n squared, this is n to the power 4. So if we double n, that's what happens. Alright, fantastic. Wait, that's it for 7.7? I wrote an entire calculator for this thing. You're only gonna let me use it on 3 questions? Aw, man. Oh, why can I close IntelliJ? IntelliJ close. There we go. Now let's full screen this again. Man, now I don't get to use my awesome calculator anymore. Oh, let me commit to GitHub. Just need a minute. Oh, don't do that. Go. Anyways, kind of want to take a little break, but at the same time, I want to get it over with. Next up, 7.8, starting at question 6. (7.8), if I remember right, we can zoom back in. Let's write it away over here. Is this a line? I don't know, but I don't really care as much anymore after what just happened. Like an hour spent on one agonizing question. 7.8. Improper integrals. Starting from number 6, we have the integral from 0 to infinity of 1 over square root of 1 plus x dx. First off, we can rewrite this to the limit as x approaches infinity. We used to use t, but why can't we use x? Well, I suppose if I have multiple infinities, if I have infinity to negative infinity, that's a problem. Of from 0 to, oh, I remember now. Yeah, I see why we use t now. T from 0 to t of 1 plus x to the power of negative 1 over 4 dx. Okay. So u is equal to 1 plus x. Let's say u is equal to 1 plus x. So actually, we don't even need to do that. Plus 1 divide. So negative. No. 4 over 3 times 1 plus x to the power of 3 over 4. Yeah, looks about right. Let's take this over. Can I not move it? How does this work? Wait, what can I select if I can't move? That's weird. Well, we'll do it this way. Limit as t approaches infinity of 4 over 3 1 plus x to the power of 3 over 4 from 0 to t. Alright, that is equal to the limit, or is it not limit anymore, over 3 infinity 3 over 4 minus 4 over 3 1 0 for n. So it's just that. And if I have an infinity, this is infinity. Therefore, it diverges. Is that right? I feel like this one should converge, not diverge. Alright, well, time to double check. 1 over 1 plus x to the power of -1/4. Go, go, go. My integral's correct. And go to infinity. And it is divergent. Perfect. Answer is correct. Next up is number 13. 13 wants to know the integral from -infinity to +infinity of x times e to the power of -x squared dx. All right, so this was a u sub. So this was a u sub. Let's say u is equal to -x squared, because why not? Du would be equal to -2x dx. So our integral would be equal to the integral from -infinity to +infinity of, wait. Let's integrate first, because I don't want to do bounds. Of no, -1/2, because there's x, there's no -2. -1/2 of e to the power of u du. Which is equal to -1/2 u from summer to summer, which is equal to -1/2 e to the power of -x squared. Wait, there's no du here. Integral of e to the power of u is e to the power of u. And this goes from -infinity to +infinity. So limit as t approaches infinity of -1/2 e to the power of -t x squared plus, actually this is from 0 to t, plus limit is, let's call t again. Might be illegal to do that, but you get what I mean. Plus -1/2 e to the power of -x squared from t 0, and this is actually -infinity. -infinity. I'm just go to, if as t approaches infinity, -x squared approaches 0. So it's the close, wait, no, it gets closer towards infinity. I'm confusing myself. E to the power of -infinity is, hello, Sid Rocco. Welcome to calculus. I'm currently confusing myself. Oh, I'm just reading off of some kind of summoning ritual to summon a demon from hell. Anyways, e to the power of negative infinity is 1 over e to the power of infinity. So that goes towards 0. Therefore, the limit of this goes to 0 plus, and if I have negative infinity, same thing, 0 goes 0. Well, we do occasionally have some cheats in place. If you got on earlier, let me see. You should still be able to see it. I actually wrote a little script to help with calculations because there was too much algebra going on. Anyways, let me close that. We don't need that. We've already done using the script. Now we're on a different section. And of course, for perfectionist purposes, goes to zoom 100. Now, convergent. Let's erase this first. Convergent. And double check answers, of course. I have to. This is number 13 for 7.8. Oh, trust me, my brain doesn't go that much further either. That's why I have a calculator. And it is 0. How convenient, our answer is correct. See, we don't have to go past 2 plus 2. We just need to work out 0 plus 0 somehow. Anyways, my favorite word anyways. I've said that like a couple thousand times today already. Number 19 wants to know the integral from negative infinity to 0 of z times e to the power of 2z dz. Alright, integration by parts. U is equal to z, du is equal to equal to dz, dv is equal to e to the power of 2z dz, and v dz. Yeah. Oh, no, stop right there, stop. No, it's not what you think it is. This is not what you think it is. It's 1/2 e to the power of 2z. Right? Yeah, right. It's not what you think it is, trust me. Oh my god, e is here too. This is too perfect. This is too perfect. We'll have d, e, and z. It's like whoever made this problem intentionally made it that way. So this is uv 1/2 z e to the power of 2z. My 2's and z's look too similar. Minus the integral of you know what's worse is when we have trig identities like sine x, cosine x, secant x. Sometimes I will just write the first 2 letters, then my brain moves too fast, then I move on to x, and I forget the 3rd character in the trig identity. And you can see where that causes some problems. You can see where it might cause some problems. Minus, oh god, vdu minus 1/2 e to the dz. So that's 1/2 z e to z minus 1/4 e to z. Exactly, the secant is the most dangerous one. And how does this work? When half z minus 1 over 4 times e to the power of 2z. And what was I doing? Oh, I was solving for limits. So this is a limit of t as t approaches negative infinity. Li. What's Li? Lithium? Huh. I have no idea what that might be. Or 2z negative 1 over 4 e 2z from 0 to t. Oh my god. No! Why does this keep happening to me? Last time we were playing Lobotomy Corporation, there was a character named Hakma. Guess what's the first thing chat said? Hakma balls. My god, why does this keep happening to me? As t approaches infinity, this approaches infinity, equals infinity. Therefore, diverges. Divergent. Is it divergent? We'll have to check. And the holy textbook says... The holy textbook says I'm wrong. No, I am not falling for that again. No. I do not lack in charisma. I have plenty of it. Wait, no. No. I do not have plenty of it. Where did things start going wrong here? Is it my integral? Or is it because my 2 looks too much like a z? Yeah, this looks like the e is sleeping. No! Not again. Negative infinity. Wait. Negative infinity. Is this a 2 or a z? I actually can't tell my own handwriting. It's a z. Negative infinity. From 0 to t. So we have... We should probably write equals here. Limit of that is equal to negative infinity times e to the power of 2 e to the power of negative infinity. Uh-oh. UFC? No, is that another one of those memes? Anyways, this is an indeterminate form, but I completely forgot about indeterminate forms. Oh, MMA? I don't know what's MMA either, so I assume I don't watch it. Oh, mixed martial arts. I do not watch that. Where did things start going wrong? I wish I used X instead of Z's, like they told me to. Let's see. double check work. Where did my integral start going wrong? No. Integral's correct. The integral's correct, but I did something wrong. Wait, I think I might know. Now that I think about it, I don't watch anything at all. I sometimes watch a playthrough video of some new games like Elden Ring. Oh, I can't wait for Elden Ring to go on sale. But aside from that, I barely watch any videos. So get 0. If you plug in 0, that's negative 1/2. E to the power of 0 is 1. So negative 1 over 4 minus negative infinity times 0, because e to the power of 2. Yeah, I don't really watch anything except for a couple of YouTube videos occasionally. Use the power of negative infinity. Ooh, indeterminate form. But exponential is greater than linear. So e will ramp up higher than infinity. Therefore, it's negative 1/2. Convergent. Oh yeah, occasionally when I'm working, I'll just have one of those Reddit meme videos playing in the background, and I'll just listen to it while I work. Anyways, that was number 19. Next up is 22, which wants the integral from 1 to infinity of natural log of x divided by x squared dx. At least not z this time. Don't want to work with a z again. My 2's look too alike. Oh man, I don't have to, because we get our homework are due online. Everything has a due date automatically. There's no such thing as collecting homework. Every homework's available. So I don't have to remind the teacher about homework. But you know, perhaps I would, if the necessity rises. U is equal to natural log of x. Du is equal to 1 over x dx. dv. Yeah, I would. I can't have anyone else in the class missing out on this awesome experience I'm having right now, where it's been like 3 hours already. Man, I'm glad you can't reach me. Look, if you're in class, you're here to suffer. Ha 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 ha. But you know, usually before I can do it, someone else pops up and they remind the teacher of the homework. Yeah, nobody likes the guy that reminds the teacher about homework, but I'd say it is the right thing to do. I have no idea how tall I am. I think I know the metric system. I have no idea how high I am. I have no idea how tall I am. I haven't measured in maybe like 2 years. Oh, dv, it's getting distracted. dv. This is dx. So the integral be negative x to the power negative 1. Perfect. Next up, we have, what just glitched? Natural log of x over x, negative natural log of x over x minus the integral of negative 1 over x squared dx, which is equal to negative natural log of x plus, or rather minus x to the power of negative, which is 1 over x, minus 1 over x. So we want to take the limit as t approaches infinity of negative natural log of x plus 1 over x from 1 to t. Okay, natural log of infinity is infinity. So this is negative wait. Natural log scales slower than linear. Therefore, this is 0, right? Natural log should scale a lot slower than linear. Double check. Natural log of x divided by x squared. Um, 1 to infinity. No, it's not 0. Is it because I forgot this 1 here? This is odd. Natural log of It's natural log of infinity over infinity. Yeah, I guess we have infinity on top and bottom, but that doesn't excuse the negative sign. It's the integrals, right? Why is it 1? Why is this 1? Oh. I am a complete idiot. I forgot about 1 here. So that's 1 minus, plugging 1 get 0, 1, 0 minus negative 1. My god, convergent. Riddle me this. Throw your riddles at me. I am not afraid of your questioning. I am, however, afraid of approximate integrals. If quizzes are quizzical, then what are... Please don't make me say it. Tests are an evaluation of your performance in school. Okay, that's the best answer I can give. 29. Wants integral from... Ooh, this is a harder one. -2, 14 of dx over worst roots of x plus 2. Oh god. Let's rewrite this. This is an integral from -2 to 14 of x plus 2 to the power of -1/4. And it seems like we would need the limit as t approaches -2 from the right of integral from t to 14 of x plus 2 to the power of -1/4 dx. All right, dx. Never forget the dx. And what am I doing? All right, integration. I don't sound like I'm from America. Yeah, I'm not from America. I have been here for a very long time though. So it's basically my primary language now, although I still have some kind of weird accent. Now, the integral of that is going to be equal to limit as t approaches -2 from the right of 4/3 x plus 2 to the power of 3/4. From the UK, United Kingdoms. Well, hello from the United States. And this is going to be from t to 14. Ooh, convergent. That means this is equal to 14 is 4/3 times 16. Right, let's write 14 plus 2 to the power of 3/4 minus 4/3 times 0 to the power of 3/4, which is fine. Which is equal to 16. That's 2 to the power of 3 is 8. So that's 4 times 8 is 32/3. I am from China. 32/3, this is convergent. Now I'm perfectly fine sharing where I'm from. It's just the nationality. Convergent, is this correct? Magical textbook. Tell me, is my answer correct for 29? It is correct! Fantastic. Next up. $32. But hey, you're really sharp because a lot of people can't really tell that I'm not from America just by listening. 32 wants to know the integral from 0 to -1 of dx over square root of 1 minus x squared. Welcome back, you're on it. How was your day? Are you ready to suffer? Anyways, we gotta rewrite this as the limit as t approaches -1 of 0 to t. Wait. Oh, not -1, 1. Hey, me too. Welcome to Sufferland. As t approaches 1 from 0 to 1 of 1 minus x squared to the power 1/2 dx. I'm gonna straight up guess that this thing is convergent. Oh, this is negative because negative 1/2 plus 1 is 1/2. That's positive. I'm gonna guess it's convergent. But we'll see. This is equal to limit as t approaches 1 of... Oh, go ahead. I love Asian jokes. Especially because they're relatable. Anyways, this is... Wait a second. Don't like this. Wait a minute. No, where's my undo? There it is. Yeah, I'm Asian. I think Lucidical was actually the first one who pointed out that I wasn't American. Anyways, this is equal to limit as t approaches 1 of 1 over square root minus x squared. That is arcsine, isn't it? Arcsine of x from 0 to 1 or 0 to t. Oh, okay. So I don't sound American, but I don't sound Asian either. I got this weird hybrid accent where I can speak neither languages, or rather I can speak either languages fluently. Anyways, arcsine of 1 is gonna be pi over 4. Wait, arcsine of 0. Uh-oh, what does it do? I do sound Asian. I can't tell what I sound like. I don't have a sample to compare myself to. And oh god, what was I doing? Do I really not know the arcsine of 1 now? No, this is arcsine of 1 is pi over 4. Arcsine of 0 is 0. So that pi over 4 convergent, my guess was correct. Convergent. Check answer. Welcome back, Lucidical. Next up. Ooh, before that, check answer and make sure my answers are right. And this is 1 over square root of 1 minus x squared from 0 to 1. Go. Charge. It is... Huh? I sounded French. I have taken French class. Maybe that's why. But oh yeah, wait. Oh yeah. I was thinking of arctangent. This is pi over 2. No. I could probably do calculus better than I can do adding like terms. My algebra is terrible. For me, calculus is a lot easier than algebra. 35 wants the integral from 0 to pi over 2 of tangent squared theta d theta. What do we call rich Asian? Yeah, I'd call them a rich Asian too. What do you call Ching? Visible confusion. Hang on. Let me check if this works. Oh, not this one. Not this one. Not this one. This one. I'm not sure I get the joke. I'm sorry. I'm not sure I get it. My brain's not working. It's fluctuating. Oh, the money sound from the cash register. Ching. Now, funny thing is, I somehow know that that is represented as the sound of a cash register, but I don't know where I've heard that from before, and I don't know if I've ever actually heard it in person. Anyways, here we can change this to integral from 0 to power of 2 of 1 minus secant squared. Wait, no. Not 1 minus secant. Secant squared theta minus 1 d theta. And that is going to be equal to power of 2 of secant squared. Actually, we don't even need to do that. I am Chinese. But I haven't been in China for a very long time. So I'm not familiar with Chinese culture. I'm more familiar with cheeseburgers and fries. Anyways, this is tangent. This is tangent theta minus theta from 0 to power of 2. Iranian, Indian, we got a diverse population here. Anyways, we're going from 0 to power 2. Tangent of 0. Sine of 0, 0, cosine 0 is 1. So that's... Hang on. Tangent of pi over 2. Cosine pi over 2 is 0. Oh no. We gotta take the limit. Limit as t approaches pi over 2 from the left of tangent theta minus theta from 0 to t. So if you draw a graph, tangent theta looks like this. So as approach of pi over 2, that goes towards infinity. Infinity minus pi over 2. I don't know, but the stereotype is very relevant. It's really not relevant, prevalent. Like, I don't know either. But when you see someone doing maths, it's almost always Asian. And when it's Asian, it's almost always Chinese. Like, the best student in my class, guess what nationality they're from. Minus tangent of 0 is 0, minus 0, 0 minus 0. Equal to infinity. Divergent. Now, holy textbook, reveal to me the truth. D? Am I on the wrong chapter? I'm sorry. Oh, D for divergent. I thought I was doing the wrong problem for a second. Ooh, we're pretty close to finish. Just gotta suffer a little more. Like through 39, which wants the integral from -1 to 0 of e to the power 1 over x to the power 3 dx. All right. This is a U sub. U is equal to 1 over x. Du is equal to, oh god, negative 1 over x squared dx. Wait, this is perfect. This is perfect. So now that is equal to integral from somewhere to somewhere of e to the power of negative e to the power of u du. Wait, no, u negative u eu du. Right. Got 2 here. That gets taken care of. Then we got 1 left, which is a u. Perfect. Seagull. And we integrate. That is a u sub, but now it's going to be a v sub. V is going to be equal to, wait, no, we can't do that. If I don't use u, my brain messes up. Okay, we're using fg. F is equal to u. F prime is equal to du. They're like seagulls. Why do you like seagulls? I like birds a lot. Like, I have a lot of things themed around birds. But from what I hear from other people, seagulls are very mean. Like, they'll murder you. They'll paint your car white. EU. G is equal to EU. And that will lead us to UEU, or negative everything, minus EU DU. Please don't tell me you train seagulls. Please don't tell me that you train seagulls at a park or something. Plus EU. Okay, anyways. That's summer to summer, summer to summer. And no, we don't need that. The seagull stole a chip? Negative e to the power 1 over x plus e to the power of 1 over x from -1 to 0. Okay, or limit is gonna be 0. Limits as t approaches 0 from the left of negative e to the power 1 over x plus e to the power 1 over x. I can rewrite this. And how did the seagull steal a chip? Was it from the bag? Did it swoop down? Oh no! No. Don't start training seagulls to steal things. Okay. X plus 1 e to the power of 1 over x over x. Oh man. You know what's even better than just training seagulls to steal rules? You should also invent a anti-seagull trap thing that would prevent seagulls from stealing their rules. So that way you create a problem and you can sell the solution along with it. Or is that too evil? I don't know. Anyways, from -1 to t. As t approaches 0, we get 0 plus 1, so we get 1 times e 1 over 0 from the left. So oh god, e to the power of negative infinity is 0. 0 over 0. Seagull trackers. Create a problem, sell the solution. Anyways, if I have a 0 over 0, we have an indeterminate form. Which is... So now what we can do is... That's... I don't like this. This is equal to x plus 1 go e to the power 1 over x. What's the derivative of that? So that's negative 1 over x squared e times 1 over x. I am heavily confusing myself. Approach 0 from the left, that means this is negative. Why does it have to approach from the left? Why can't you take some other route? Anyways, x plus 1 times 1 over x squared, negative 1 over x squared, e to the power 1 over x. That looks terrifying. Oh, armored seagulls with flamethrowers. You're creating an army now. That does not sound very pleasant. Plus e to the power 1 over x. Over what? So I've did this right. This is equal to 0. Times infinity, negative infinity, times e. That would be infinity 1 over infinity. Hang on, could I have done this an easier way? This is equal to limit Oh yeah, speaking of music, I really like electric music. I've actually got the license to use a playlist of music on streams, so let's actually bring that up. I completely forgot I had one. Let's see. These are all by Real. Let's pick a random one. Let's pick a newer one. And let's lower the volume a little. Can you hear it? Dubstep. I like dubstep too. I think actually, I don't know if there's any dubstep in this playlist. I actually can't even hear it. Might be a bit too loud. Yep. Limit as t approaches 0 from negative of... Wait, is this whole thing negative? Oh no. X plus 1 over... No, that's not negative x. No, I can't do this. Oh man. X plus 1, that's 1 times 1 over 0 from... So that is a infinity. It's a square infinity times e to the power 1 over x, or x power to the power negative 1. So e to the power of negative infinity, e infinity, or square root infinity faster. Ouch, not the door frame. Hang on, e to the power of negative infinity. Another one? This is another indeterminate formula? Unless I'm doing something wrong. Let me double check. E to the power of 1 over x divided by x cubed. Did I do integral right? My integral is perfect. But now, the limit. I have no idea what this f without a bar is. Here's the thing. Limit as x approaches 0 from the negative side of x plus 1 e to the power 1 over x is 1 times e to the power of negative infinity over 0 from negative. So that is 1 over 0 times e to the power of infinity, which is not good. Equivalent to the not good. But wait. The infinity of exponent is greater than the infinity of a linear equation. I think I can just work with that. Oh, I like the new eraser. Uh-oh, not the lag. It's from negative infinity over 0 from below. So that's 1 over 0 times e to the power of infinity. Wait, so e is going to be greater. If that's the case, then this should be 0? No. Let's graph this. E to the power of 1 over x divided by x to the power of 3. Yeah. That's a 0. But now we get 0 minus negative 1. We plug in negative 1, we get 0 equals 0. Convergent. Right. Actually, no. It can't be 0, can it? Let's see. Magical textbook grants me the knowledge I seek. 39. Yeah, no, not this. So if that is 0, negative 1. We plug in negative 1. That doesn't make sense. I don't see anything wrong with my integral either. Where does the textbook get that from? Gotta double check. It should in theory approach 0. E to the power of 1 over x divided by x. Yeah, it approaches 0. Don't see what's wrong with this. Did I miss something? What is the question? From -1 to 0 of e to the power 1 over x divided by x cubed, yes. Ah! X... wait. I see how this... I see how this... Guess what's the problem? Take a guess. I'll give you a hint, it's not a calculus problem. It's a simple fact that I forgot a negative sign. So that is that is 1 -1 over 0 minus times e to the power of infinity. E to the power of infinity wins over the 0. Therefore, that is 0. This has to minus, plug in -1, we'll get -2 e to the power of -1 over -1. So that's 0. That cancels out, minus 2 e to the power of -1 equals 2 over e. Convergent. I like convergent integrals because they have numbers, and I like numbers. Next up, number 50. Use the comparison theorem from 1 to infinity of 1 plus sine squared x over square root x dx. Okay. So 1 plus square root x, we can say that is less than or equal to 2 over square root of x. And now if we can prove 2 over square root of x to be convergent, then we can prove that. So let's do that. From 1 to infinity, of course. 1 over infinity of 2x to the power 1/2 dx. This is 3, so that's 4 over 3 x to the power of 3 over 2 from 1 to infinity. No, that's divergent. Or is it? Yeah, that's divergent. Then we can say this is greater than or equal to 1 over square root x from 1 to infinity. Integral from 1 to infinity of 1 over square root of x, or rather x to the power 1/2 dx is equal to 2 over 3 x to the power 3 over 2 from 1 to infinity, which is equal to infinity. Since 1 to infinity, this entire integral is greater than or integral Wait, no. Actually, yeah, yes. Because sine squared x is always positive. So that's always between 1 and 2. Here we have 1. And this integral is divergent. By direct comparison. The direct comparison test, or integral. Hang on, did I forget to public? Really? All right, let me fix that. The integral is, let's see. Oh my god. Did I forget to publish all these? When did I do this? Save. Save. Thank you. See ya. Thank you so much. Alright, published. And wow, it's been 3 hours already. Is divergent. So there we go. See ya later, Shadow Nail. I'll make sure I don't mess this up again this time. I'll make sure this calculus video gets published to the world. Anyways, next up we got 58, which is in fact our last question. 58. 58 wants to know the integral from e to infinity. E to infinity. Sounds like a punchline. Of x times natural log of x to the power of p dx. Oh my god. Find values of p. This single question is gonna take me an hour. Find values of p where integral converge and diverge. This singular problem is about to ruin my day. How would I go about this? Ooh, U sub. Let's see. U is equal to natural log of x. Du is equal to 1 over x dx. We can rewrite the integral as e to the power of infinity of 1 over u to the power of p du. Right? Actually, we can't have the bounce here. That is u to the power of negative p du. And that is going to be equal to 1 over negative p plus 1 times u to the power of negative p plus 1. And that is assuming p is not 1. So we need p equals 1, p greater than 1, p less than 1. If p is equal to 1, let's take care of that last. Let's first think p greater than 1. Actually, let's do this. This is equal to the integral from e to infinity of 1 over negative p plus 1 times natural log x times negative p to the power of negative p plus 1. All right, there's our integral. So natural log of e is 1, natural log of infinity is infinity. That part's all natural. So what we do need is limit as p approaches, or as t approaches 1 of the... This is not an integral. This is not an integral. So this is from e to infinity. For all that. Perfect. And what was I doing? Hang on, what am I doing with this? Oh yeah, I remember now. This is limit of 1 over negative p plus 1 natural log of x negative p plus 1 from actually p is always greater than 1 because p is e. Therefore we get natural log of infinity to the power of negative p plus 1 over negative p plus 1 minus 1, no, natural log of e, which is 1 to the power of anything is 1. The natural log of e, that's 1 over the power of negative p plus 1. Find values of p where it's convergent divergent. If... Am I doing this right? Yeah, if p equals 1, then as our variable x approaches infinity, then wait, if p is equal to 1, we don't need natural log here. As x approach infinity of negative 1 plus 1, 0. Anything to the power of 0 is 1. Then down here, p cannot be equal to 1. So that is divergent. Okay, as x approaches infinity, f of x approaches infinity along with it. Wait a second though. This is confusing. I have done a similar problem to this, so where is that? Improper integral. We've done one problem like it, but my god, was it a lot easier than this? Or was it? Well, there it is. First, took the limit. Then, ooh, if p plus 1 is less than 0. Ooh. Wait, where's this minus 1 come from? Is it approach greater than 0? Use the power of... Wait, why did I write converge here? This is not converge. This is diverge. Okay. I think I got the gist of it now. Alright, let's see. If p equals 1 as x approach 1, natural log x, negative p plus 1 approaches infinity? But wouldn't it approach 1? I think I just confused myself in a brand new way now. Let's see. Let's go to the limit as t approaches infinity of 1 over negative p plus 1 times natural log of x times negative p plus 1 from e to t. All right. As if negative p plus 1 is greater than 0, as t approach infinity, natural log of t to the power of negative p plus 1 also approach infinity? Wait a minute. Wait, no. Yeah, I was right. Hang on. We need to keep doing this. If p is greater than 1, then as t approaches infinity, if negative p plus 1 is greater than 0, then yes, it approaches infinity. If negative p plus 1 is less than 0, as t approaches infinity, natural log t to the power of negative p plus 1. So let's say 1. This approaches O. What was I doing? Oh, P is less than 0. This is less than 0. That means we approach 0. If negative P plus 1 is equal to 0, as T approach infinity, natural log of T to the power of negative P plus 1 approaches 1. Is that right? What format do you expect the answer to be in? This is an even number question, therefore I cannot check answers. Okay. P is greater than 1, then natural log of x over negative P plus 1 to the power of negative P plus 1. Huh? Oh, evaluate values. Now I'm even more confused as what this question wants. If P is less than 1, divergent. If P is greater than 1, then the integral of that thing is natural log of E. Natural log of E is 1, so we get if we approaches 0, so we get 0 minus 1 over negative P plus 1. Yeah. And if P is equal to 1, so we get, shouldn't this be divergent? Because of this. I need reference once again. Draw straight lines. Wait, I can draw straight lines? Whiteboard tips. Ooh, I like that. I like straight lines. Yeah. Let's did approach infinity. I also approach infinity. Wait, what? Wait, what? 1 over x diverges. Let's see. All right. Wait, no. This is not the one. Should be the second one. Microsoft Whiteboard can be quite slow at times. if p is equal to 1, so that's t approaches infinity. So natural log infinity is infinity. It still approaches infinity. But that's 0. What? No, it was 1 over. Let's try it. 1 over x times natural log of x. P negative p plus 1 is 0. So p is 1. Oh yeah, it is divergent. So if it's equal to or less than 1, then it's divergent, right? 1 second. I think that's it. Hooray! Ooh. Anyways, p is greater than 1. There we go. That is all for today. That was pretty clean. And while we were at it, we also kind of cheated a couple problems by writing some code. And if any of you guys are following my Minecraft server, we just did finish a pretty big update. I still haven't wrote the changelog yet because I have so little time and so much to do. But anyways, thank you guys for watching, and I will likely see you maybe next week. I don't know if I'll stream this Saturday. But anyways, you guys are awesome, and I'll see you next time. Bye bye.